So one of the more important applications of the integrating factor is being able to solve the drag equation for free-falling objects. So say we have a falling object who is being affected by air resistance, and the air resistance is proportional to its velocity, so k times v. And obviously the force of weight is going to be mg. So obviously we're going to go back to Newton's laws, which is force is mass times acceleration. And we're just going to sum up the forces. So mass times acceleration is v prime, is equal to mg, the force of weight, minus kv. And here we're taking that velocity in the down direction is positive. That's an important assumption that we're making. And so let's rearrange this. So mv prime plus kv is equal to mg. Let's divide everything by m. So v prime plus k over mv is equal to g. And so right off the bat, we can just use our integrating factor. What's our f of x going to be? It's going to be k over m. So we're going to take our integrating factor. It's going to be e to the power of the integral of k over m dt. Let me label that if. And what's it going to equal to? It's going to equal to e to the power of k t over m. And so right after this, we're going to multiply everything by e to the kt over m. And so e to the kt over m times v prime plus e to the kt over m, it's supposed to be an m, sorry, times k over mv is equal to ge to the kt over m. And so right off the bat, we can see, well, this is just product rule. So, because remember, the derivative of e to the kt over m is e to the kt over m times k over m. So we can just rewrite this as e kt over m times v, all of that prime. And that's equal to ge to the kt over m. And so we're going to integrate both sides with respect to time, and we'll get e to the kt over m v is equal to ge to the kt over m times our chain rule piece of m over k. And we of course have to add the constant plus c. Now we're going to rearrange the terms, and we're going to solve for v. So our v is equal to, if we divide by e to the kt over m, we're going to get c e to the negative kt over m plus g m over k. So it's going to be c e to the negative kt over m plus g m over k. And so if we apply our boundary value conditions, we should find that since our falling object, we defined it to start at velocity 0. And we've also defined that at time infinity, we should reach terminal velocity. That's why parachutes work. They reach terminal velocity. So based off of those boundary value conditions, if v of 0 is equal to 0, then this entire equation, we're going to get a negative gm over k. So then this works out to be v is equal to gm over k, because if the c is negative gm over k, then we can just factor the whole thing out. Gm over k times 1 minus e to the negative kt over m